Hello everyone, hope you're having a good day. My name is Prasanjit Singh and today I'll discuss about Graviton instances and about my experience taking the Graviton challenge by AWS. So I came across the information about this Graviton challenge going on from one of the Slack groups I'm a member of, because I am a AWS community builder as well, and I was interested about knowing more about what Graviton processes are and how they work. So I took this challenge, and this is a monologue, you can say, of my experiences using Graviton processor on AWS. So before we discuss more or dive deep, let's understand what AWS Graviton processors are. Well, AWS Graviton processors are custom built by Amazon Web Services using 64-bit ARM Neoverse cores to deliver the best price performance for your cloud workloads running on Amazon EC2. Now, Amazon EC2 provides the broadest and the deepest portfolio of compute instances, including many that are powered by latest generation Intel and AMD processors. AWS Graviton processors add even more choice to help customers optimize performance and cost for their workloads. These are, believe me, very cheap, like they would come at around 40% of normal instances of the same capabilities. Well, that's a different story. We'll discuss that towards the end. The first generation AWS Graviton processors power Amazon EC2 A1 instances. I remember using that around 2018 after the reInvent where it was announced. So I think I gave it a go around 2019 for one of our instances that ran Neo4j graph database servers, and it worked pretty well for a A1 instance. And then I happened to forget it, and until this Graviton challenge came and my curiosity rekindled. Now, these instances deliver significant cost savings over general purpose instances, as I said, and that can go up to 40% better price performance comparable to similar sized instances. Now, the current generation is AWS Graviton 2 processors, and they deliver a major leap in performance and capabilities over these A1 instance types. And according to tests, they deliver 7 times more performance, 4 times more compute cores, 5 times faster memory, and 2 times larger cache size. So a really new generation with augmented capabilities. Now, let's move on to the Graviton challenge I took and what I did there. Well, what I did here is spin up a Graviton instance. So it's same as choosing any flavor of instance type and launching an instance in EC2. So that part is almost similar to how we launch EC2 instance. Just when choosing the instance type, you choose something from the Graviton based instances, and remember it should be the Graviton 2 generation instances. So there are many types of these, like you have general purpose M6G, M6GT, T4G, these kind of instance types. You have compute optimized instances like C6G, C6GD, C6GN, and so on. And you have memory optimized types like R6G, R6GD, X2GD, and so on. So these are the nomenclatures. So choose any one of them. I chose the simple one, T4G, and launched a EC2 instance using this Graviton processor. And my intention was to build a Spring Boot Java instance, because I use Java Spring Boot for my applications that I host in Kubernetes or ECS. So I wanted to create an image of a sample Spring Boot application, containerize it, and deploy it on the Graviton instance. If that was successful, I would later on build a Graviton instance as a worker node in ECS or Kubernetes, and I'll save money when deploying my ECS clusters. So that is the agenda. Well, but there is a catch here, because the Docker containers that are built are normally the Docker images when they are created using, say you're using a build tool like Jenkins. So the Jenkins server is not a Graviton based instance. So the primary architecture is, say, x86. So when the instances, Docker images are created, built on a x86 system, they would not run properly on a Graviton. Like, they wouldn't even run at all, because the architecture isn't compatible. So to overcome that, we have to build even the Docker image on a Graviton instance so that it can run on a Graviton. So Docker has an experimental feature called BuildX that allows you to build multi-arc Docker images in one go. So you can build multiple architectures of Docker images. Normally, what do we type in when we create or build a Docker image? We type in Docker build and then tag -t, and then we name the image with the tag, and then we put a dot in the end to denote that we are going to create from the files that are present in the current directory. So that is how you build a Docker image. But instead of Docker build, you type in Docker build X in this case, where you have when you are planning to create multi-arc images. Well, so first you have to, once you have your EC2 instance up with the Graviton 2 processor instance, you have to first install Docker. That would be pretty straightforward. I installed Ubuntu on this system, and I did apt-get install Docker. So that was it. And then I prepared a file, a Docker file with all the directives to build my Spring Boot Docker image. And to start using BuildX, we use the command docker buildx create, and then we created a namespace and created this Docker image. And once the image was created, I hooked it on to ECR, and I pushed this image to ECR container repository. And of course, I created a repository beforehand in ECR and then pushed my image. And then I also ran this image manually on my Graviton instance, and it worked. And then I attached this Graviton instance in my Kubernetes cluster as a slave. So what I did for that is to have, I already had a K3s cluster, and I just installed the K3s ARM script here and attached this as a slave to the original K3s master node. And then I was able to run my container image by pulling it from ECR, and ran this as a pod So that's how I was able to deploy a Spring Boot application by building a Docker container having Java Spring Boot in it and deploying my application there on a Graviton True CPU based instance. So that was my experience. I'll try and experiment more with Graviton 2 and see how the cost saving turns out to be. Till then, stay tuned. Thanks for listening to my experience. Thank you.